Okay, so let's say that you have a couple of given roots, and what you want is to write the equation up. So suppose the roots are 5 and negative 2/3. We can say x equals 5. We can say x equals negative 2/3. And then here, this would be x minus 5. Over here, if you multiply by 3 first, and then if you add the 2, that becomes 3x plus 2. So then you take these two factors, write them side by side, and multiply them out. So we'd get x minus 5 times 3x plus 2. Distributive property, you would get back 3x squared minus 13x minus 10. You can call this y equals, and you're done. This would be your polynomial in standard form that the roots of it are 5 and negative 2/3. We've done examples like this kind where the roots are real or imaginary, but we haven't done a problem where the roots are like this. So this is where the new stuff comes in. So let's say the roots are 2 plus square root 3. So jot this down somewhere. And its conjugate, 2 minus the square root of 3. So let's suppose these are the roots. Well, it follows the same steps as the other problem. We can go x equals 2 plus square root 3. X equals 2 minus square root 3. And now bring everything to the side of the x. The first one would go x minus 2 minus square root 3. Here, do the same thing. Bring them to the side of the x. That would say x minus 2 plus square root 3. And now we have to multiply these out. But when you multiply these out, it's going to be blue, blue, blue. It's going to be pink, pink, pink. And then it's going to be green, green, green. You see that? It's distributive property. But this is a trinomial. Trinomial, that's 3 times 3 is 9. We're going to have 9 pieces there, and then we're going to combine like terms and be done. So first, do all the blue stuff. Distribute just the x. And let's see what this gives us here. Get this out of the way. This should give us back x squared minus 2x plus x square root 3. And then do the pink. That should be minus 2x plus 4 minus 2 square root 3. And then finally, do the green. That should be minus x square root 3, and then plus 2 square root 3, and then minus 3. Now look at all the pieces here. There should be 9 pieces. 1, 2, 3, 4, 5, 6, 7, 8. There are 9 pieces. Of the 9 pieces, cancel out whatever cancels. Here it looks like this cancels with this. It looks like this knocks this out. It looks like that's it for cancellation. But what can we combine? We can combine this with this, and we can combine 4 with negative 3. So final answer down here in blue should be x squared minus 2x plus 1. And call this y equals, if you'd like. Done, done, done. Final answer. You can actually test this for accuracy on Desmos. If you graph your answer on Desmos, I believe you get a parabola that looks like this. And it has 2 x-intercepts. And one of the x-intercepts will be a decimal. And I think they're actually both decimals. But their exact forms would be this number here. And for this guy, it'll be that one there. Right? You can check your answer on Desmos by graphing it and seeing that the decimals you get are the approximations of those exact numbers. Okay? So let's do one more, and then we can call it a day. So how about the same idea, but this time the roots will be imaginary. So let's go with 1/2 plus or minus I square root 7 over 2. So we have 2 roots, a conjugate pair. So let's go x equals x equals. X equals 1/2 plus I square root 7 over 2. X equals 1/2 minus I square root 7 over 2. Now, the previous problem, it was kind of nice. It was kind of fast. And that's because there was no fractions. Here, we have fractions everywhere. So recommendation, get rid of the fractions. Here, what can we multiply both sides of both equations by to get rid of all the denominators? In this case, 2. So multiply every term by 2. And here is what we will get. It'll be 2x. This will be 1. And this will be I square root 7. 2x. This will be 1. And this will be negative I square root 7. And now move the stuff to the side of the x. Move everything to the side of the x's. This will give us 2x minus 1 minus I square root 7. And this other one would give us 2x minus 1 plus I square root 7. And then distribute everything out. Foil everything out, all 9 pieces. Fully expand this. And here should be the 9 pieces. 4x squared minus 2x plus 2xi square root 7. Then distribute the negative 1. Minus 2x plus 1 minus I square root 7. And then distribute the negative I square root 7. Minus 2xi square root 7 plus I square root 7. And then minus I squared 7. 1, 2, 3, 4, 5, 6, 7, 8, 9 terms. All 9 are there. Let's see what cancels. So this knocks out this one. And let's see this one. This one here. Let me get my marker back. There it is. This one knocks out this one. And then what combines? Let's see. Here we have this one combines with that. And what about what about what about this guy? I squared is negative 1. So negative I squared is positive 1. And then positive 1 times 7, all this is just 7 in the back. And that 7 combines with the 1 to give us back 8. So final answer, it looks like it would be 4x squared minus 4x plus 8. Let me go y equals. This is one option. You could turn this in for 100%. The team next to you, right, the other people, they could say this. They could say y equals x squared minus x plus 2. So let me explain why this is okay, and then you guys can leave. So the reason this blue one is also good is because this blue one has the same roots as this original one. You see here, I noticed that I can reduce everything by 4. So if I divide by 4, divide by 4, divide by 4, I would get this here. Now, these graphs of these two equations are way different, but both of these polynomials have the exact same roots, the ones that were given originally. You see that? So can you reduce these guys by a number? Sure, you can reduce it if the goal is to write an equation that has these roots. But again, these are different pictures, but they have the same x-intercepts. Here is a quick visual before you go. Maybe one of them looks like this, and maybe the other one looks like this. You see that? Different graphs, different parabolas, but they have the same x-intercepts. So I would be willing to accept either one of these. You don't have to give me both. Either one will suffice. So this is basically what we did today in class. And tomorrow we will continue from here. Okay, so hopefully this helped. You guys have a nice day. Bye.